In, yeah, in slippers. All right, you guys, Pythagorean identities. So let's write these out for like the millionth time to make sure we really got this. So the first one is cosine squared x plus sine squared x equals 1. You're going to need to know these on the test tomorrow. So now I'm going to divide everything through by cosine squared. So let's go with Aaron. If I divide this by cosine squared, what do I get? Hold on. Divide cosine squared by cosine squared. Yep. Now I'm going to divide sine squared x by cosine squared. And Hannah, what do I get? Yep. Good. And Jake, what do I get when I do 1 divided by cosine squared? Nice. All right, now I'm going to divide everything through by sine squared. So Kelsey, what do I get when I divide this by sine squared? Good. And I divide this one by sine squared. Anna, what do I get? This one right here.
Oh,
1. And Thomas, this last one, what do I get? Good. All right, so now let's solve this problem. So we've got 3 cotangent squared x minus 5 cosecant x plus 1 equals 0. So the goal is to factor these, but in order to factor, they all have to be the same trig function. And we always change the one that's squared, because you can use your Pythagorean identities if you change the one that is squared. So I'm going to keep the cosecant one, and I want to change this cotangent squared x, hopefully to cosecant squareds. So let's look at our identities up here. And this guy has cotangent squared in it. So we got to isolate it and substitute it in. So what can we replace cotangent squared x with, you guys? Did you guys just get one? All right. So we have a 3, and we're going to substitute in cotangent. So you guys, cotangent x is equal to what? Yeah, cosecant squared x minus 1. Then I have minus 5 cosecant x plus 1 equals 0. So we need to distribute it and put it in like nice quadratic form here. So I'm going to distribute this 3 here to here and here to here. So this is 3 cosecant squared x minus 3 minus 5 cosecant x plus 1. And combine like terms and put it in order. So I want the squared term first. And then I want this cosecant term next, minus 5 cosecant x. And then I'm combining like terms. I have a negative 3 and a positive 1, so that's a negative 2. Now, for some of you guys, it helps. Remember, we replaced these with a variable, and I was told not to use x, so I'm going to use a. So this could be like 3x squared minus 5a minus 2, and then it's just some factor tractoring. So I'm looking for what multiplies to be this times this. So 2 numbers that multiply to be negative 6 and add to be negative 5. What? Good. So I rewrite this as 4 terms. So I'm going to do negative 6a plus 1a in the middle. Remember, we replaced that middle one with the 2 factors. Then we factor by grouping. So we're looking for a GCF. What comes out of the first 2 terms? 3 and a. And that leaves me with a minus 2. And then what comes out of the second 2 terms? A positive 1. And that leaves me with a minus 2. Those have to match, right? Or you messed up. Now what you factored out, 3a plus 1 goes in one set of parentheses, and a minus 2 goes in the other set of parentheses. And now you can replace those back with cosecants, just cosecants. So I have 3 cosecant x plus 1, and at the same time I'm going to set that equal to 0 because I'm solving. And then for a, I'm going to replace it with cosecant x minus 2, also equals 0. All right, I'm going to isolate this cosecant x, so I minus 1, and I divide by 3, so that's a negative 1/3. And over here, I'm going to isolate this guy, that's a 2. So this would be the same thing as if I flip it so I can get the sign. I can flip this one and this one. Is there anywhere where the sign is negative 3? All right, so this guy is a no answer, not possible, okay? And then over here, this is where is the sign 1/2. So sine is the y, positive 1/2, positive 1/2. And this is when you should check if it's radians or degrees. So I'm going to check right here, and we are in degrees. What'd you say? Yeah, so I just always forget to do that. That's why I was saying that so aggressively. So what is this one, you guys? 30 degrees. And this one is 150. These are so fun. I like these. All right, we have one more. We got to do it. We got to do it. All right. What if Colin needs this one, or Corey, or who else is absent? Evan. They're going to hear their names in the videos. Evan was here. He was in my class earlier. All right. So cosine squared. So you guys, we have a sign here. We want to get them all in the same thing, and we always change the one that's squared because it's one of the Pythagorean identities. So go back to this. And what is cosine squared equal to? That's great. 1 minus sine squared theta equals 2 sine theta plus 2. So now I've got to put it in order. So you guys, this is a minus sine squared. I don't want to have a negative x squared or whatever. It's easier if you put that on the other side. So I'm going to put 0 on this side, and I'm going to move the sine squared over here so it's positive. So I have a positive sine squared theta, and then I have a plus 2 sine theta. And we also need to subtract this 1. This is a positive 1, so I'm going to subtract 1, and I get a plus 1. I probably would not need to replace these with a's because I can do this in my head, especially since there's not a coefficient in front, right? So I can just say sine theta times sine theta is sine squared theta, and then I need two numbers that multiply to 1 and add to 2. That would be plus 1 and plus 1. If you want to factor it long ways, though, you can. So then you set each of your factors equal to 0 and solve, which is sine theta equals -1. It's the same on both, so I can just do it one time here. So where is the sine, the y part of the coordinate, equal to -1? And let's see if we're in degrees or radians. Oh, we're in radians. So what radian is that? I'm going to go with 3 pi over 2. Okay.